Hello, this is the recording for the Unit 4 homework, and this is just the front page. So here are the activities and assignments you have to do for this unit. It's a typical thing: homework, quiz, practice test, practice exam, and then of course the other things that are feeding into it, like watching the Mechanical Universe videos. So I'm going to go quickly through this one here. Learning objectives here, so pay attention to those. This particular unit covers 3 chapters which are somewhat different but also somehow related. So they're talking about circular motion, they're talking about orbital motion, which is also circular, but it's also kind of like satellite motion, which is circular or elliptical, but it's also talking about projectile motion, which is parabolic. So anyway, so I put these 3 chapters together. Here's the homework quiz, which I'm going to get to in approximately half a minute. This here, of course, the 90-page Word document, which I called a WAPA, Worked Out Problems in Physics, that you should have, as many of the computation problems, I take that back, all of the computation problems are in it. Then these are my videos that are posted on YouTube, and there's a good overlap with this one here, with the printed one, and a lot of these are also on the computation problems on the practice test and the proctored exam. In this case, actually, it's a non-proctored exam. These are new, actually, the rotation experiments. So I made several recordings, and I think it's just one long recording, but the homework problems are quite extensive, 5, 6, 7, and 8. So I will get into that in detail when we look at the homework. And then, of course, there's the typical how everything works that you have to read through, and the typical Mechanical Universe videos, in which this time around you have to watch actually 3 of them, as I said, since there are 3 chapters. Okay, let's go ahead and look at the homework. Okay, so first question, just say yes to all of these, because I'm assuming that you're going to do all of these. Second question, that's a typical thing: choose an exercise, type it out, make sure that you reference it nicely where you got it from, and then answer it. Third one, just a moment ago we looked at the objectives, and as far as I know, I think all of these apply. So if you go back, then you will see, well, the 3 chapters that we're doing here, yes, all of these objectives apply, but double check that. This one here, that of course goes to the Worked Out Problems in Physics, the 90-page document that you should have. You can almost go across here and say, okay, it's a speed, v equals 2.1. Well, it's either meters per second or kilometers per hour, if that's on here. Oh, there's 1 kilometers per hour. I think in this case it's 2.1 meters per second, but of course I do want you to actually look at Chapter 8, Problem 2 in my Worked Out Problems. Force, of course, very likely newtons. That's down here. There's the answer for that. Mass, 1, very likely kilograms, but again, double check that. The little t here, by the way, should be the Greek letter tau, which is used for torque. As I had mentioned before, all the symbols that we have in physics, almost all the symbols that we have in physics, go with the English language. So usually that works out like capital F for force, lowercase v for velocity, because uppercase V is for volume. And by the way, lowercase f, uppercase f is force, lowercase f is frequency, by the way. But of course, the lowercase t is time, so we need something else for torque. So physicists figured that for something that's rotating, let's use Greek letters. So that's why you see the strange looking T here, which is actually the Greek letter tau. And then so on. So I really urge you to go through these worked out problems, work through them, and then match up here. So I'm not going to give the rest away. You look it up. All right, so this one is new. So there is this video about rotation experiments that I did in part with one of my sons, maybe both of them. I think one of them, Benjamin. It was a few years ago. So you go in there and you watch the experiment, and we pretty much give the explanation away, which I also have here. So Benjamin narrates a few, I narrate a few, and I think he was about 10 around that time, maybe 11 when we did this. And then you're trying to match it up with the concept. The concepts that you see on the right-hand side, notice that there actually is quite an overlap, like this one here: rotational inertia, moment of inertia, rotational inertia, moment of inertia, angular acceleration, same thing. And then there's one slight difference, as in rotational energy, center of mass. So try to match them up in the best possible way. It's a little difficult because of the way it's worded here. But as you see, I'm actually giving the answers away here. Of course, as you scroll down, you kind of the explanations here on the left-hand side are quite long, so you're losing the statements that you need to match up with on the right because they're scrolling up while this one here is scrolling down. So hoop, solid disc, then there's a stick that we're trying to balance, then frozen juice and liquid juice. I believe actually I did that with Nicholas. I'm pretty sure, my younger son. So he must have been 8 around that time. Weighted stick and the hammer, trying to balance them, a weight. Then something about the broom. Then we go on, because these questions are so long here, or my explanations are so long, that's why I split it up into 4 parts, but I think there's only one video. In order to nut on a bolt, dishes on a tray. Dishes on a tray, I know that top of my head, is Newton's second law twice. Once for that the torques are balancing, right here, and once that the forces are balancing, which is why a tray becomes really tough to carry when you're actually holding it on the side instead of the middle, because you have huge torques acting on it. Triple beam balance, which by the way works on torque, so let's see what the answer for that. Yep, torque right there. The dumbbell, throwing the dumbbell, that's probably Newton's third law. Yep, there it is. For the board, in this case for forces and torques, Newton's laws, as they apply to forces, they also apply to torques. So for example, something that is in rotation will stay rotating. The Earth, by the way, is a good example. The Earth just keeps rotating and rotating at a constant 23 hours, 56 minutes, and 4 seconds. Close enough to 24 hours. That's not rounded, by the way. But the length of the day is actually different from the rotation of the Earth, slightly different. Okay, so for the board to balance and so on. So again, look at these videos, and these here will make more sense. These are just the explanations, but in the videos you will see what the experiment actually is. And here's yet another one: swirling cup, each object, car. This one I think is just, this one is show and tell. I think I have like a car there, and then I have a little airplane and so on. Dumbbells again, turntable, that's kind of a fun experiment. Turning wheel again, this one as well here. That's actually about gyroscopic motion, at least it should be. Let's see if that's true. Ooh, no, it's conservation of angular momentum. Oh, okay, that's the, oh yeah, turn the wheel upside down, that's what that one is. But then there should be one more about the gyroscope. Yeah, there it is. And then the kendama, which is a Japanese toy. And the snow shovel experiment. And for that one, I have a 4th one here, where you can see me measuring on a snow shovel. That's also where I had hit myself in the head. Let's see if I say that somewhere here. I thought I did. Yeah, I put the force spring scale onto the shovel, and then it slipped, and then the handle of the snow shovel hit my forehead. All the stuff you do for recording physics videos. So here you're supposed to compute something, and then you're supposed to compute something else over here. So notice that only 3 of these here have 2 answers to them, so it should be either this or this or this. Oh, there's another one. Hold on. Take that back. One moment. I didn't pay attention here. Oh, okay, never mind. Because there are multiple answers. I think if you calculate this one here, oh yeah, it's right here. 34 pounds at 1 foot, but then you have another lever arm of 2 feet, so that cuts the force into half, which is 17 pounds. But then the left arm also has to hold all those forces, so there's like the force of the load, which is 34, then there's the force exerted by the right arm pulling upward, and then there's the mass of the shovel itself, or the weight of the shovel itself. So 34 plus 17 plus 5 is the 56 pounds over here. All right, then Bloomfield here, you read through it. This one is about the seesaw. Top of my head, lever arm should apply there, force should apply there. For some odd reason, I put the word force in here twice, oh well. And then torque should apply there. And then you have to look at other things. Probably angular acceleration, mechanical advantage is in there. I mean, it's a seesaw. So read through it and check the correct answers. And the last one is the mechanical universe. Again, this time it's 3 videos, so you have 15 quotes here. And again, I give away these here, in which order these are. So here's the first one, and then the next 4 from the first video. I believe these quotes are in reverse order, so double check that. I mean, watch the videos. And the 6th one is from the next videos. This is about Kepler's laws. So again, the next 4 quotes after that are probably in reverse order. And then this one is the 11th quote, which is from the last video, the 3rd video. And again, the quotes are possibly in reverse order. And then, yeah, figure this extra credit question out. Okay, let me just go back to this one here. So here you have the mechanical universe. Watch these videos. You have to click on this link here, read through the book, this extra book here, watch my rotation experiments recordings, and I think there's only one. It's relatively short for all the experiments that I did. And this one here, I basically gave the answers away. And then here, watch my videos on how to do the computation problems, and these are the worked out problems. And that's, of course, what you're working on is the homework quiz, the learning objectives. All right, that's it for this recording.